In this video, we're going to take a look at multiplying rational expressions. And multiplying rational expressions, if p divided by q and r divided by t are rational expressions where q and t are not equal 0, then p divided by q times r divided by t is equal to p times r divided by q times t. And it says, in other words, to multiply rational expressions, multiply the numerator and multiply the denominator. So for number 1, it says multiply in right and lowest terms. So what I'm going to do is multiply everything in the numerator and then everything in the denominator together in one fraction and then simplify. So here in A, we're going to have everything in the numerator is 3 times 1 times a cubed times b times a times c to the third. And that was everything that was in the numerator. And then we have 4 times c, and then we have ab squared. And remember, that's the same as a squared times b squared. So we have times a squared times b squared. And now I'm going to simplify using the laws of exponents. So I have 3, and then I have a cubed times a, which gives me a to the fourth. And I have a single b, and then I have c cubed, divided by 4, and there are no like factors in the denominator, so I'm just going to rewrite it in order. A squared, b squared, and c. And now 3 and 4 don't simplify, so I'm going to end up with a 3 left in the numerator, and then I have a to the fourth divided by a squared gives me a squared, 4 minus 2. I have b divided by b squared, which would be b to the negative 1 in the numerator, so I'm going to write it in the denominator with the 4 as a single b. And I have c cubed divided by c leaves me c squared. In b, we have x squared minus x minus 6 divided by 3x minus 9 times 2x squared minus 5x minus 3 divided by x cubed divided by x squared minus 3x. So again, I'm going to write this as numerator times numerator and denominator times denominator in one fraction. Divided by, we have 3x minus 9 and x squared minus 3x. And now I want to write as many of these as I can in linear factors. So I have x minus 3 and x plus 2 for our x squared minus x minus 6. And then we have 2x squared minus 5x minus 3. So I'm going to have 2x and x. And then in order to get negative 3, we're going to have negative 3 and 1. So I'm going to have negative 3 here and positive 1 divided by, I can factor a 3 out of 3x minus 9. So I'm going to have 3 times x minus 3. And I can factor an x out of x squared minus 3x. So I have x and x minus 3 again. So we can see that we have 2 factors of x minus 3 in the numerator and 2 factors of x minus 3 in the denominator. And they're going to cancel each other out, and we're going to be left with x plus 2 times 2x plus 1 in the numerator. And we're going to be left with 3x in the denominator. In example C, I have x minus 5 divided by 5x squared times 25x divided by 25 minus x squared. So I'm going to rewrite it as one fraction. X minus 5 times 25 times x divided by 5x squared, and then we have 25 minus x squared. And now I can rewrite this as 25x times x minus 5, and now we have 5x squared in the bottom, and then we have 5 minus x times 5 plus x. And if you remember that x minus 5 and 5 minus x are additive inverses, so that equals -1. So these two terms will give us a negative sign. And then 25 divided by 5 is 5, so we have a 5 in the numerator. And we have x divided by x squared, which would give us x to the -1 in the numerator. So we have x in the denominator. And then we have 5 plus x also remaining in the denominator. When we take a look, the two constants simplified to give us this 5. The additive inverses of x minus 5 and 5 minus x gave us our negative. X over x squared gave us this x. And then we had the remaining 5 plus x term. And that's where all the pieces for that came from. And that's our video on multiplying rational expressions.